Let's take a look at the seniors and the juniors separately. And we'll start with the seniors because we know more about them. There are 5 seniors that are able to serve on the committee, and 2 of them must be chosen. In the last problem, we saw a formula for choosing a certain number of elements from a set. In this case, we're looking at 5 choose 2, which was equal to 5 factorial over 2 factorial times 5 minus 2, which is 3 factorial. You can use a calculator if you've got an advanced enough calculator to do this right away, but you can also do it out by hand. 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. The 3's, 2's, and 1's will cancel. 5 times 4 is 20, divided by 2 is 10. So there are 10 possibilities for the seniors. We want there to be at least 600 different possible ways to pick the committee. So what we want is there to be greater than or equal to 60 ways to choose the juniors. Because the seniors and the juniors are separate. If there's 10 different ways to pick the seniors, 10 different combinations, and each of those has 60 different combinations for the juniors, that's going to lead to over 600 different possible ways in total. So what we need to do is we need to look at n choose 3, and we need to figure out the value of n. In this case, we can do some guessing and checking. We could start by saying 8, for example. If we had 8 choose 3, that would be 8 factorial over 3 factorial times 8 minus 3, which is 5 factorial. And in the last problem, we already saw that that was 56. And unfortunately, that ends up being too small. If we try 9, 9 choose 3 is going to be 9 factorial over 3 factorial times 9 minus 3 is 6 factorial. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And then 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. The 6's and 5's and 4's and 3's and 2's and 1's cancel. If we look what we're left with, we've got 9 times 8 times 7 over 3 times 2 times 1. And we can do some more reducing here. 9 and 3 are both divisible by 3. We can reduce by 3. That leaves us with 3. 8 and 2 are both reducible by 2. That leaves us with 4 and 1. And then we have 3 times 4 times 7 is 12 times 7, which is 84. This makes us happy because it's greater than or equal to 60. And that means we need at least 9 junior volunteers, which is answer choice D.